For Tapia Carmen, and this is my Physics 2211 Lab 5. For this lab, we got to choose anything we wanted, as long as we hadn't done it before, like as a lab. And I chose to do conservation of momentum, aka elastic collisions. So procedure: grab two carts of equal mass, a track, and magnets to attach to the end of each cart. Second, use a laptop and to be able to use like a tool like tracker and track the velocity and more data of each cart. And then create a computational model of the experiment. Third, observe whether energy and momentum are conserved. Physics, we're using Newton's third law of motion, which basically states that um, if two things, it's like equal and opposite reaction. So in this case, momentum of the system at the beginning equals momentum of the system at the end. But since it's a perfectly elastic, the first cart is transferring all of its momentum to the second cart. And this is the video. As you can see, the second cart we leave at rest first, and then the first cart's the only one that moves. However, then the first cart stops, and the second cart is the one that keeps on moving. Yep. All right, code. My glow script is right there. So this was the thing that took me the most time. The mass one, I just did. Both masses I knew were equal to each other, so I just did one because it really didn't matter. The cart, I represented each cart with a sphere because it's still like a dot of center of mass. Um, yeah, and I made the first one red and the second one blue. The velocity of the first at the beginning I said was 0.1. I tried including the original velocity from the experiment. However, it wasn't working, so I had to make it a little bigger, and that was probably due to error in the tracker app. V2 is 0 because the second cart is at rest. Delta T, we're doing increments of 0.01, and then our end time was 10 seconds, just to make sure there was enough time to properly showcase the experiment. Down here, we made a while loop until the time happened, so 10 seconds. Cart position, we just did position update formula for both of the carts. At the beginning, V1, so cart 1 moves, and then that cart 2 has a V2 of 0, so it doesn't move. However, this if statement allows it to, it basically says that once they're in the same position, that V or aka collide, V2 switches with V1, and then we make V1 0 0. So the velocity of the second cart becomes 0, and the velocity of the first cart becomes 0, and the velocity of the second cart becomes just takes up whatever the previous velocity of the first cart was. And then we continue the while loop, and we print the collision at what time it happened. This is the code. It kind of looks like the left one, the red ball is moving to the left now. However, the blue one's moving to the right. All right, what if? Back to this model, you can see that conservation is conserved. However, in the real one, it's not because we have like friction and stuff. So yeah. All right, what if question? Think about adding more mass to the initial cart and it starts with the same V1. How would that affect the collision? Basically the first the first mass has to, if let's say it was 2m1, uh the velocity of the second mass would have to double as well, so it'd be 2v2 because the mass of the second one is still m1. Air, we have friction, air with the tracker app, air resistance, and then it's really hard to uh simulate a real life perfectly elastic collision. Thanks for watching.